technology stuff, but I didn't want you to miss out on anything, so I need you to get your notes out to the section that says 7.3 and 7.4. I combined both of those sections because we're both dealing with elimination. Okay, so this is going to be the third way we're going to solve systems of systems of equations. So elimination, just by definition, is when both x's or both y's, they have to have the same coefficient, but they have to have opposite signs. We want them to have opposite signs because we want them to eliminate, and we're going to add the equations together. Okay, so I'll give you a few seconds to write that definition down quickly, and then we'll move on to some examples. Alright, we're going to go ahead and move on and start with our first two examples. So if we look at example number 1 and we think back to the definition of what elimination is we want to look at our two x's or our two y's, and we want to look for the same coefficient, but we want them to have opposite signs. So if we look at example number 1, we look at the x's and they both have a 3. Right? And the top one is that -3, so that satisfies our condition of one being negative and one being positive. So what we're going to do now is we're going to treat this like it's an addition problem, and we're going to draw a line underneath both systems, or the system of equations, and we're going to, if it helps you, put a little plus sign outside of it because we're going to add everything together. Well, we know when we add -3x and 3x together, that gives us 0x, so we don't have to write that. So we're going to move on to my y's. We're going to treat it like it's a different column. So now I have 4y plus a -6y, which gives us -2y. Equal sign always stays the same, and then we want to add 12 plus 18. And 12 plus 18, we know, gives us 30. Well, this just turns into a one-step equation like you guys are all used to. So in order to solve for y, you might guess that we need to divide by -2, which means y takes on the value of -15. And just like yesterday, when we solved for one of our variables, that wasn't it. We had to get the other one. So now that I know y, I have to solve for x. Okay? And then the way we do this is we pick from our original system one of our two equations. And I'm going to pick the one with the positive x, just so I don't have to deal with dividing by a negative. So I'm going to rewrite 3x minus 6y is equal to 18. And now instead of having this y right here, I'm going to replace it with that -15. So if you rewrite it, it's 3x minus 6 times -15 is equal to 18. And now we just have to follow the system, or our order of operations, and we have to multiply -6 times -15 to give us 90. So now we've got 3x plus 90 is equal to 18. And then to solve this, you will remember that we need to subtract 90 from both sides. So go ahead and subtract that 90, and you get 3x is equal to -72. Divide both sides by 3, and we find that x is equal to -24. So now we have our number for x and our number for y. And just like yesterday, we want to go ahead and write these in an ordered pair. And that ordered pair is going to be -24, comma, -15. And that's how you would solve a system of equations using elimination. Okay, so let's go ahead and go over example 2. So again, we're going to look for variables that have the same coefficient, and if we look at number 2, we notice that both x's have a coefficient of 1, and both y's have a coefficient of 1. So now it really comes down to which one is negative and which one has a positive. Well, you'll notice on the y's, one y is negative and one y is positive. So I want to go ahead and eliminate my y's, because if I add negative y plus y, it drops out. So again, if it helps you, put that plus sign outside, and we're going to add each column. So x plus x gives me 2x. We've already established that those y's are going to drop out. So 2x is now going to equal 34. And just like we did in number 1, we're going to divide by 2 on both sides to get a value of 17 for x. So now that we know x, I want to pick one of my 2 original equations from the system to solve for y. So I'm going to plug it into my second one because that y is negative. So I'm going to start with x plus y is equal to 20. And in for x, I'm now going to put 17 plus y is 20. Now to get y by itself, subtract that 17, and I know that y is now equal to 3. And then the last thing we need to do is make sure we write it into an ordered pair, and that would come out 17, 3. So if you remember what I said yesterday, if you were to graph these 2 equations on your coordinate plane, this ordered pair is where your x and your y, or your 2 lines would intersect. Alright, let's move on to your next examples. If you look at both of them here, you'll notice in number 3 and number 4, our x's in number 3 and our y's in number 4 have the same coefficient, but they're not opposite signs. Okay, well, there's a really easy way to get them to be opposite signs. What we want to do is pick one of our equations and multiply it by a -1, because we know that doesn't change any of our numbers, but that's going to change the signs. So I always multiply the bottom one by the negative. It's just a habit of mine. You don't have to do the same. So if I change that bottom one to be multiplied by a -1, it's going to change to -4x plus 3y is equal to -18. So remember, it changes the sign on every single number. And now, I don't have to worry about that equation. So now I satisfy my 2 conditions. My variable has, or one of my variables have the same coefficient, but they have opposite signs. So I'm going to go ahead and add these 2 equations together. And 4x plus -4x gives me 0x, so I don't have to write anything. 2y plus 3y gives me 5y. And 28 plus a -18 gives me 10. And if I divide both sides by 5, I know that y is equal to 2. So now we need to know what x is. Alright, so I'm going to take the very first equation, 4x plus 2y is equal to 28. And since I know y is 2, I'm going to go ahead and replace that y with that 2 and solve. So this turns into 4x plus 4 now is equal to 28. We need to subtract that 4 from both sides, and we get 4x is equal to 24. And I know I have to divide both sides by 4, which means x takes on the value of 6. And if I write this as an ordered pair, my ordered pair is going to be 6, 2. And we do the same thing for number 4. So I'll let you guys do number 4 right now, and I'll make sure I put up the answer at the end of this. So go ahead and pause the video, please, until the students are done. Alright, now that we're done with number 4, we're going to work on number 5 and number 6. They're a little bit different only because if you look at your 2 variables, x and y, not only do they not have the same coefficient, but they don't have opposite signs either. So what we need to do is we need to pick out whatever variable we want to eliminate. Okay, in number 5, what I'm going to do is I'm going to pick the y's to eliminate. Just like I did in example 3, I want to multiply an entire equation by a number that's going to get the opposite of the coefficient from the second equation. So if I'm dealing with number 5 and I want to eliminate the y's, I need to get a -2 in front of that y in this first equation. Okay, which means I need to figure out what 1 times something gets me a -2. Well, I know that that's possible by taking this whole first equation and multiplying it by a -2. Okay, so -2x times 2 is -4x. Negative y times -2 is -2y, and that's going to equal -46. Okay, so I'm going to cross out that top equation because I'm done with it. I've changed it to what I need it to be. And now I'm just going to add these two equations together because I see that my y's have the same coefficient, but they're opposite signs. They both have a 2, and one's negative and one's positive. So when we add these together, I get -x is equal to -9, which means x has to be equal to 9. So now what I'm going to do is I'm going to take one of my two original equations, and I'm always going to deal with the one where the variable is positive. So I'm going to take 3x plus 2y equals 37. And instead of that x, I'm going to replace it with a 9 that I just solved for. And my equation now becomes 27 plus 2y is equal to 37. If I subtract 27 from both sides, I get 2y is equal to 10, which means y is equal to 5. Okay, but I'm not done yet because I haven't written that as an ordered pair. So finally, to write this as an ordered pair, it's going to be 9, 5. And now you're done with the problem. So what I want you guys to do is the same thing on number 6. Okay, I want you to pick either the x's or the y's to eliminate. And to be quite honest, it's going to be easier if you pick the variable to eliminate with a set of variables that one has a coefficient and the other one doesn't. Okay, so in number 6, you look at your x's, both of them have coefficients. But you look at your y's and they don't. Okay, so that top y has a coefficient of -1, or there's a -1 implied, and the bottom one has -4. So I'll get you started, because in order to transform this first one, I need to go ahead and multiply it by a -4, because not only do I want it to have a 4 in front of it, but I also want that y to turn positive. So when I multiply that whole equation by -4, it turns into -8 plus 4y is equal to -24. Now, those two equations are the two that I want to add together. Okay, so if I add those together, I know that I get -5x. Those y's drop out because one's negative and one's positive, and that's going to equal -26. Okay? So now I want to divide by 5, and here's where you all need to remember it's okay to get fractions as your answer. When I divide by -5, I get x is equal to, and I'm going to leave it as 26 over 5. But what you have to pay attention to last two examples deal with when we have to multiply both of our equations by a particular number in order to get the variables to eliminate. So I want to find variables, hopefully that one is already negative and one's already positive. That way I don't have to multiply anything by a negative number. So if I look at number 7, I notice that I have my y's, one's already negative and one's already positive. So now I need to find the LCM, or the least common multiple, that 3 and 5 have in common. And I know that that's 15. So now I need to figure out what I need to multiply the top equation by to get 3y to go to 15y. Well, I know 3 times 5 is 15, so I need to multiply both equations by, that top equation by 5. Okay, so the top equation is going to be 4x plus 15y is equal to 40. And I need to do a similar thing to the second equation, except I need to figure out what 5 times what is going to give me 15, and I know that that's 3. So I'm going to multiply that bottom one by 3 to get a new equation of 9x minus 15y is equal to negative 69. And I notice that this 4y needs to be a 20. So please make that change if you wrote down the incorrect coefficient like I did. Okay, so now this just becomes like our very first problems. I know that my y's can be eliminated, so I'm going to draw a line under both of those equations, add a plus sign, and I'm going to add the x column, the y column, and the constant column. So this is going to become 29x is equal to negative 29. And I know because I have to divide by 29 on both sides, x has to be equal to negative 1. And so I need to find what y is. So what I'm going to do is I'm going to pick one of my very original equations because I deal with smaller numbers, and I'm going to plug negative 1 in for x and solve. To me, the easiest one's going to be the top one. So I'm going to choose to pick 4x plus 3y is equal to 8, only because the y is already positive right here. I don't have to worry about dividing by a negative. So what I'm going to do now is replace that y with a negative 1, and I'm going to solve like I normally do. Oops, not the y by a negative 1. I'm going to replace the x with a negative 1. So this becomes negative 4 plus 3y is equal to 8, not 18, equal to 8. Okay, and I want to add that 4 to both sides to move it. So this is going to turn into 3y is equal to 12. And now we have to divide both sides by 3 to get that y is equal to 4. And the last thing, as always, is to write this as an ordered pair. So your ordered pair here is going to be negative 1, comma, 4. And that's your solution. Alright, so moving on to the very last example that you're going to do. It's similar to number 7 because our coefficients, none are the same. But it's different because all of the coefficients are positive. So at this point, we're left with no choice other than to multiply by one of them by a negative. I'm going to choose to eliminate the x's just because they're at the front. You could choose to eliminate the y's. So if I look at the coefficients of my x's, this 4 and the 6, I know that their LCM is 24. Okay, so I know that my x's have to start with a 24. Well, in order to get 4 to be 24, I need to multiply this first equation by 6, which is going to turn into 24x plus 42y is equal to 36. And then I want to multiply this bottom one by 4, but I need it to be negative, so this has to be multiplied by negative 4. And this is going to turn into negative 24x minus 20y is equal to negative 80. And now we're set to go because I can eliminate my x's when I add these two equations together. So 24x minus 24x gets me 0. 42y minus 20y is going to be 22y equal to 36 minus 80 gets me negative 44. If I divide both sides by 22, we find that y is equal to negative 2. Okay, and so I'm going to plug this negative 2 in for y into one of my original equations and solve for x. So I'm going to go ahead and use 4x plus 7y is equal to 6. Okay, and instead of having that x in there, or I'm sorry, that y in there, I'm going to have a negative 2 and solve like normal. So this is 4x minus 14 equals 6. If I add 14 to both sides, I get 4x equals to 20, which means x has to equal 5. And then your last step here is to write this in an ordered pair, which would be 5 comma negative 2. In your packet, you have a word problem at the end of this. We're going to save that until tomorrow when we're in the lab. So don't worry about that, and you can find your assignment down at the bottom of your page of notes. I hope this all makes sense. If it doesn't, shoot me an email or we can work on it a little bit on Wednesday. So I will see you tomorrow, guys.